Hi, welcome to lesson 6 where we're going to be looking at forces. Today's learning intention is really revising forces at National 5 level and the effect they have on objects. We're going to be doing some calculations that all should be done with National 5 level physics, but on the other hand, you can be asked these types of questions at Higher too, and Higher doesn't really actually go that much further with them. So, we're starting off with what we learned in first year. So forces can change the speed, shape or direction of an object. That's hopefully something you're fairly familiar with. I think it's important to point out at this stage that the opposite is also true. If the speed, direction or shape of an object changes, then a force must be acting on it. So any time that you have in particular for us really, the speed or direction of an object changing, then you've got to have a force acting on it. So if something's accelerating or it's turning around a corner, then a force must be acting on it, and that's something you've got to be aware of. When we're talking about forces, we are talking about Newton's laws. You kind of need to know these laws. You need to know them off by heart. The important thing about these laws is that they describe, well, three situations really. The third one's maybe a little bit different, but we're really mainly looking at two situations. The first one is about balance forces. And if a balance force acts on an object, then it must either stay stationary or move at a constant velocity. Now, stationary is actually a constant velocity of 0, so it is basically just moving at a constant velocity. Anytime you see the words constant velocity, stationary, or balance force in a question, then you know that this must be that Newton's first law must apply. And you've got to start recognizing that and putting these keywords together with the concepts that they represent. Okay, Newton's second law is about unbalanced forces. If an unbalanced force acts on an object, then it will accelerate in the direction of that unbalanced force. So anything that's accelerating must have an unbalanced force acting on it. Newton's third law is about pairs of forces. We've done this a lot last year, but the full version is if object A exerts a force on object B, then object B will also exert a force, an equal and opposite force on object A. An alternative version, the way of thinking about this is really that whenever anything applies a force to any object or any body, whatever it is, applies basically a force to another object, then that object must apply a force back. You cannot have one force just acting on its own. There has to be an opposite force, and there are absolutely no exceptions to this. And that's kind of a weird thing to think about, but it's absolutely true. When we are standing on the surface of our planet, we are pulled downwards by the Earth. So the Earth actually pulls us downwards, but bizarrely, we're actually pulling back upwards on the Earth with exactly the same force. So if our weight is 800 newtons, then we're actually pulling the Earth towards us with 800 newtons too. Okay. I've got 2 or 3 examples here. And they're deliberately not starting at the very, very beginning. Because we're at a higher level, I expect you to have a certain background knowledge for this. Again, if you don't have this, or if you're not sure about this, please go back and have a look, preferably before the start of term. Please go back and have a look at the Scholar materials or the BBC bite-sized materials on forces. Scholar's probably more useful, but if you're really not sure, have a look at BBC bite-sized first of all. So the graph that's shown in the bottom right here shows the motion of a car. So this graph here is showing us the motion of a car. At this particular point here, we've got it's going at a constant velocity. How do we know that? Because it's a horizontal line. The engine force is 4,000 newtons. What's the friction force after 2 seconds? Well, after 2 seconds, 2 seconds is here, so it's in the constant velocity part of the graph. And this is where you have to really recognize that we've got a key word here, the key phrase here, constant velocity. We're talking about forces. What's that about? Well, that must be about Newton's first law. And this is one that probably the most important techniques you need to have at a higher level. You need to be putting these concepts together. So constant velocity, horizontal part of the graph. You wouldn't normally have a wee arrow in a text box here saying constant velocity, but horizontal part of the graph, constant velocity must mean Newton's first law, balance forces. What does balance forces mean? Well, it means that the engine force must equal the friction force, if these are the only two forces acting in the car. So, If the engine force is 4,000 newtons, then the friction force is going to be 4,000 newtons too. I've kind of summarised that in the box here. It is really important that you know that you have this stuff in the background, because what we're really doing, what I've done in this question, or what you will have done in this question if you did it, is you would be taking the fact that we've got a speed time graph, and I think everyone knows that this horizontal bit, the speed time graph, means a constant velocity. We're then basically taking that fact and we're putting it together with Newton's first law, and Newton's first law is saying that the forces must now be balanced. We've put the forces in a diagram, and balanced must mean equal and opposite. So in this case, we're basically talking about the fact the friction is 4,000 newtons. Now you need to be able to do these, and you need to have a good understanding. And that's what I think I really, really want you to get. At the beginning of the course, you cannot leave it till later on. You must make sure you understand the concepts. Not just learning off facts. That's not really going to work. Right? It's not just about learning words. You need to know the facts, but then you need to understand it. You need to be able to picture it in your head. And you need to get enough practice that you can actually start connecting these facts up. If you do that, physics can actually become quite an easy subject. Physics is a subject that relies on prior knowledge to a certain extent that you've built up over a few years, or you've built up over a course, and you need to have that before you can really move ahead. So please put in the time to understand. Right, this is Newton's second law. You might recognise this graph here. The graph's got a constant velocity section. It also has a constant acceleration section. Well, it has two constant acceleration sections. One of them with a positive acceleration and one of them with a negative acceleration. The data we've got here, we've been given one extra bit of data, and that's the mass of the car. It's asking for the friction force after 1 second, but basically the rest of it is kind of very similar. The engine force is 4,000 newtons in this case. Well, again, it might look hard, but as long as you know where to start, then it's okay. So how do you know where to start? Well, you have to learn how to do these kind of questions. The more of these questions you do, the easier it is to know where to start. Because once you've done enough, then you realise that they actually just repeat each other. First of all, what do we know at 1 second? Well, we know that the acceleration can be calculated from the graph. Again, this is going back to prior knowledge from the previous few lessons on speed time graphs. You've got to do the lessons in order. The acceleration can be calculated from the graph. The engine force is 4,000 newtons. Okay, that's fine. But that's not going to be able to tell us what the friction force is here. Because the friction force isn't going to be equal. It's not going to be equal because it's not an acceleration. Because it's an acceleration. It's not a constant velocity. So in that case, we need to know the unbalanced force first. And we've got the mass. Well, if you've got a mass and you've got forces, then there's a fairly good chance you're going to be using a little equation that you should know quite well. Right, so how do we calculate the acceleration? Well, we can do it with the gradient of the graph, or a equals v minus u over t, which is essentially the same thing. Because we've done this in previous lessons, I'm not going to go over this in any detail. It ends up being at 1 second the gradient of the graph is going to be 2 meters per second squared. The engine force is 4,000 newtons. Okay, we need to get the unbalanced force first. So the unbalanced force we can get from this equation, F equals ma. Remember, F stands for unbalanced force. That's why I like you to write it as fun, because then it gets the idea and it sticks it in your head a little bit better that this has to be the unbalanced force. So we've got the mass and we've got an acceleration. It's always safe to use a mass and acceleration to calculate a force. The dangerous thing is when you actually just put a force into here and you're trying to calculate the mass of the acceleration. You've got to be careful. Any force in here has to be the unbalanced force. That's the source of almost all errors with these kind of questions. If the unbalanced force is 1600 newtons, which is what we've got, then that also tells us the difference between the forces. That's what unbalanced force means. Unbalanced is basically the difference between the two. The engine force must be bigger as it's accelerating, and it must be 1600 newtons bigger. So friction is 1600 smaller, which means that friction is 2400 newtons. Okay, this is a Newton's third law question. And this is the kind of question you might be asked in terms of having to explain something. And it says that the mass of a car parked on a horizontal road is 800 kilograms. Using your knowledge of physics, explain what is stopping the car from accelerating down the way. I think the most obvious answer would be the ground. And while it's not strictly speaking, or you could argue that it's actually correct, we've got to be really, really careful with this. If you're being asked to answer something in physics, you can't just come up with an answer like this that doesn't really involve any physics words. Okay, what is the ground actually doing to stop it accelerating? Well, a much better answer would be that the weight of the car is pulling it down. And as it isn't accelerating, Newton's first law tells us there must be an equal and opposite force pushing back up the way. What's that caused by? Well, if you push down the ground pushes back up on you. And that's called the reaction force, because it's reacting. The more you push down the ground, or the more you push down a tabletop, the more it will push back up on you. It's called, the reaction force only exists because you are pushing down. Newton's first law basically says that because it's not accelerating, that the forces must be balanced. Newton's third law says that the weight the car pulls it down, the road must be pushing back up with an equal and opposite force. So I've actually stated, I've linked this to two separate Newton's laws. They do seem very similar, and they are in many senses in this situation, but the point is they're two separate points. And it's really important that you get them in there. Also state the obvious, the weight of the car is pulling down. Everything that you know about the question must be stated. Okay, so slightly different version of this. This time we're asked what's the force exerted by the car. And again, this is something that you've got to really be in good habits for here. The answer is definitely not 800 newtons, and it's definitely not 800 kilograms, because that's not a force. You must make sure that that you calculate the weight first of all from the mass, and then after that you can basically say that the reaction force is going to equal the weight, so it's 7,814 newtons too. Okay, this might look a bit hard, but we've got a rocket of mass. This is the typical kind of, I say hard Nat 5 type question, but it's something that you can be asked at higher in a slightly different context. If you can do these questions, then to be honest with you, higher stuff isn't actually that much harder. It's just slightly different order and slightly different context. So a rocket of mass 12,000 kilograms, which is a fairly small rocket, is launched from Earth. Its engine thrust is 150,000 newtons. What's its initial acceleration? Well, the steps you have to go through here are listed here. You always must start with a diagram, and you must add every force that's acting on the rocket to it. Now, just be a wee bit careful here. It does say calculate weight below, so that gives you a bit of a clue about what one of the forces are. When it says what's its initial acceleration, it quite often asks, these kind of questions quite often ask just as it starts to take off. That means you've got no air resistance, because it's not moving. It's just starting to move. It has no velocity really. So, if in that situation you don't need to include air resistance. The steps you take, as I say, you always start off the diagram, adding all forces to it. After that, it depends what's being asked. In this case, you're going to calculate the weight, then you're going to calculate the unbalanced force, and then you're going to calculate the acceleration. Sometimes you have to do it in a different order. But what I'm going to do is I'm going to give you a wee chance to try this question and then to check your answer on the next slide. So pause the video here. Because I've got a time limit here, I'm going to go through this very quickly. It does say at the bottom, don't round down numbers until the final answer. It's really important. I've added the forces to the diagram there. Calculate the weight in the normal way. Calculate the unbalanced force. Well, that's the difference between the thrust going up the way and the weight going down the way. And then calculate the acceleration using E equals F over M. Very important. F is unbalanced force. Yep, check that out. That works out there. That's okay to put in there. Sometimes these questions are slightly different, and you're asked for different things and given different data. So you might not be given all the data that I've given you. You might be given something different. But basically, you just swap steps 2 to 4 around. Okay? But remember, the only unbalanced forces can be used